Hello everyone. In this video we are going to create a VGA interface between the FPGA and a monitor. A prototype of the design will be implemented on the Terasic DE1-SoC FPGA board and to display triangles on a monitor. So the first thing we need to do is we are going to create a new project wizard. I'll go here, I'll click just next, and I will choose a folder for our working directory. I'll go here, download, so I'll call it VGA project. Sorry, VGA project, okay. I'll select this folder. So for the name of the project inside the Quartus, I will call it top VGA because we will have more than one file, and this top VGA file will be our top level entity. Now we will have empty project. I will not add anything for it. I'll click next. Then I need to bring the files that we need for our project. So I save them here. These files were provided by our professor for this course. So I will copy this file image generator and the top VGA with the QSF file that we need and the VGA control with the SDC constraint synopsis constraint files that we need to the design. So I'll copy them, copy, go to the download and just paste them here. Okay. Now we have got all the required files to implement our project. So I'm gonna add them to the project. Just these 3 files, all right, for now. And good, they have been added to the project. And next, in this part I'm going to choose the family device and board settings. Since we are using the DE1-SoC board, we will need the device family that ends with C6. I will copy it here, I'll copy it here, copy and go just in the name filter because we have a lot of devices inside the available devices tab. So I'll just click here and I choose it so I don't get any mistake to choose another one. Next. Now for our simulation, I will choose Quista, Intel, and VHDL programming language. Next, this is the summary for our last project. Then it will be created. I'll click finish. All right, so right now we have prepared the video VGA project. Let me see if I get all the files here. All right, this is the top VGA file. I'll set it as top level design. If I open it, I will see it with all the details inside it. This is the generator file that we need beside the VGA controller. So for now, we will work only with the VGA controller because the monitor, and here as we can see in the VGA controller, this is the parameters that we need to set up for the monitor, like for the horizontal pulses and horizontal pixels, horizontal vertical pulses and vertical pixels, all these kind of stuff. So for my case, I'm going to use a screen with a resolution of 90/20 for the horizontal pixels and 188 for the vertical pixels, and with the refresh rate of 16 Hertz. So I'm going to change these parameters for now to make them suitable with my screen. So if I want to add them, the professor have provided us with a table so we can take all the information from it, like here the refresh rate. If the refresh rate, the resolution is 640 by 350, we will take this information and put it inside the file of the VGA controller. So for my case, we don't have the resolution for my monitor, so I went and used to give the information to ChatGPT, and he provided me with this information. So I'm gonna copy these parameters for my design, and I will just comment these parts and then just paste them here. Okay, so I just finished giving the VGA controller the exact parameters that my monitor is working on it. All right, so I'm gonna save this change, and after that I will go to create the PLL that we need for the design, which is the divider clock frequency that we need, as we can see here in the project. So as we can see here, this is the project we are going to implement it. Right now I have the image source and the VGA controller. I have set up it, and I will create the PLL clock frequency divider for our design. So I will go here from IP cores, I will go to clocks, PLLs, and I will choose this one, PLL Intel FPGA. So I will give it the exact name that has been required from us to give it by the professor. So it is DCM underscore Altera. So I will copy this one. Okay. And paste it here. Variation file type, I'll choose VHDL and I click OK. Now it's logging the wizard that should we provide the clock divider for us. Okay, so the general information will go with the reference clock frequency. It's gonna be like 15 megahertz, 50, and the desired output clock for my case, it will be for the monitor, it will be 148.5 megahertz. This number we can get it from the resolution and the refresh rate of the monitor. If you do some calculations, you will get finally 148.5. You can use simply GPT to get it. So after that, if you can see here, this is the out clock 0 and locked. We don't need this, so I'm gonna uncheck this one, and that will be our PLL clock divider for the project, and I'll click finish. Okay, so right now it's generating the PLL Intel FPGA for our design, and I will wait for it until it's finished. It's finished. All right. So it's gonna take some time, like 10 or 15 minutes to finish. Once it's done, all right, I will click on exit, and we can see the PLL on the navigation, project navigation here, with all the details and the information with it. So right now we have done all the 3 parts which are required by the project. Right now I'm going to compile the design and see if we pass it or get some error. All right, so I will click start compile. So right now it's compiled the design. I will come back once it finishes all these processes. Okay, so for now we passed the fitter and assembler will be done, and the other parts until they are finished. Okay, so next thing we're going to do is to import the QSF file that contain all the pin assignment that we need for the FPGA board, and then we are going to create the SDC file, the constraint design timing file that we need to the design. So right now everything went fine. I'll go to the assignment and import assignment. I've already copied the file, the QSF file, which is this one from the design, and we'll click OK. Next thing, I'll make sure we have assignment editor, yeah, and all of them are imported successfully. So next thing, I'm going to create an SDC file. I've already put the SDC file from the project. So the design, I'm going to choose all just to see the SDC file that I copied. Okay, this here. So I'm going to copy these clock constraint details, which is 20 nanosecond, which means 15 megahertz, and I'll go create new file, synopsis design constraint file. I'll copy them here, then I will save it and give it exact name as the top level design file, and click save, and I will not need this anymore. And our next step will go, I will go to the setting to see if the SDC file added successfully to the design. So from timing analysis analyzer, yes, it's already added. Great. So I'll compile the design because as you can see here, everything is changed. So I'll compile the design right now, and our next step will be displaying the project on the monitor. Actually, for this part here, I just used my laptop, and once we are finished from compiling the design, I used the monitor from our lab, and I attached it to the FPGA board via VGA cable, and I run it. So I will show you in the next part how to download the SOR file on the FPGA board and see the result. So I'm gonna wait till this finish. Okay, now the timing is done after that, and everything is going perfect. So right now I'm going to display a video from the lab where I did the FPGA part on it, and I will display it right now in the next few minutes. So okay, so here as you can see, we implemented the FPGA board. I turned it on, and as you can see here the code, and I went to programmer, clicked on it, and I'll choose the device for the FPGA. Then I will choose the second choice, click on OK. So as you can see here from my laptop, I will go through all these configuration things. After I finish, I will upload the SOR file to it. So I will delete this one, I don't need it. And now I will add the SOR file by going to the output files folder and choose it, click on open, and this is the SOR file we have. After I done, I will click on start. Now the screen will be displaying the cell. Now it's uploading. So great, as we can see here, this is to the square on the display, and everything is perfect. And thank you so much for watching the video.